Once again, we are coming back to the second session in the subject of mechatronics. So before I will be going in for the today's session, I would like to tell you one important thing here. Just I wanted to review what all we have discussed in the previous session. What is mechatronics, importance of mechatronics, mechatronics systems, types of systems, in types of systems, measurement systems, control systems, open loop control systems and closed loop control systems. So I am sure all the students have taken a lot of benefit of the same, and one thing is to be noted is that whatever the notes that we are sending, whatever the video presentations we are sending, you require to listen to it. If possible also you can download. So whenever time is there, you just listen to them so that all your doubts will be clarified. Now today's session, we would like to start with the generalized measurement system. So we know one thing very clear, that whenever we want to go for the design of a mechatronic system, the mechatronic system can be used for two important purposes. So the first point is it can be used for the purpose of measurement of a particular physical quantity. The physical quantity may be a temperature, force, pressure, whatever is there. And at the same time, the same mechatronic system can be designed for the purpose of controlling that parameter. The best example is what we can consider as the air conditioning or heat system. Heat means whatever we want to control the temperature in the room can be set as per our requirement. Then we can go for the measurement of that temperature so as to control and so as to keep in the room in a particular temperature. So before we go for that in detail, so let me explain about if you are going to see here generalized measurement system, that is physical quantity to be used or quantity to be sensed. So here what we are going to do, there are three important elements of a generalized measurement system, okay, or sometimes it can be also called as simply a measurement system. So in the measurement system you are going to have three important elements. So the first one is called as a sensor, second one is called as a signal conditioning unit, and the third one is called as a data presentation. So as you are going to see in this particular block diagram, you have to understand the physical quantity to be sensed. Just I have explained, the physical quantity may be anything, maybe a temperature, maybe a force, maybe a pressure, whatever, that is called as a physical quantity. So why it is called as a physical quantity? Because that quantity will go on changing the value, okay. And sometimes the physical quantity can also be called as an analog signal, because again we are going to study in detail about the signals, that is about the analog signal, digital signals, what are their characteristics, how we are going to convert analog to digital, all those things. But here you need to understand that the physical quantity to be sensed may be a force, may be a pressure, may be a temperature, may be anything, and that quantity to be sensed is that signal is sent to the sensor. Here the design of the sensor decides for what purpose it has to be used. For example, the design of the pressure sensor is different, the design of the temperature sensor is different, like that. And that sensor senses the physical quantity to be sensed, and it sends its detected quantity. As you are going to see, detected quantity will be sent to the signal conditioning unit, okay. The main purpose of a signal conditioner, okay, is to amplify the signal. A very general definition is, a general understanding of the signal conditioning unit is, it basically sees, that is, it is an element wherein it is the signal conditioning means what? Whatever the signal that is given as an output from the sensor, it has to be conditioned. It has to be conditioned means what? It has to be made perfectly ready in all respect, okay, without any noises, without any disturbance. That is why it is called as what? Signal conditioning unit. And if you are going to see here, the sensor and the signal conditioning unit both are non-electrical quantity. Non-electrical quantity because here we have got the measurement of the physical quantity to be sensed, then that is given to the sensor. The sensor in turn gives out the output to the signal conditioning unit. Okay, then that signal conditioning unit will condition the signal that is taken by the sensor, then it converts into an electrical quantity. This is very, very important here. Most of the physical quantities are converted either in the form of a voltage or in the form of a current, generally in the form of a voltage. So that is why that is called as an electrical quantity, and that can be represented as a data presentation. But whatever the data presentation is there, that data presentation is nothing but a display of the value which you want to measure as a physical quantity. So that means, for example, if at all you are going to have a pressure sensor example, we can take an example of a pressure sensor where it is required to be measured as a physical quantity, and then you are going to get the data presentation as a display of a pointer. Whatever the display is there, it is called as a pointer moving across a scale, and this scale again it is of two types. One is called as a analog scale. So analog scale is what? Whatever you are going to study in the labs, in our labs, for example, if you consider in our hydraulics lab or MT lab, all the scales where we are going to use, they are called as what? Analog scales, because we are going to take the measurement with the help of a pointer moving on a scale. That is why it is called as a analog scale. Okay, or analog meter also you can call. Similarly, sometimes it may need to be converted into a digital display. The same can also be given back to the comparator, which we are discussing in the next concept. But you need to understand that this is called as what we can say as the physical generalized measurement system. So any generalized measurement system should have three important elements. So again, to go deeper into this section, again just I would like to tell you here the same one I am repeating. Of course, input is a true value, sensing element, sensor, signal conditioning element, signal processing element. Sometimes we may require one more element, signal processing. Whatever the signal conditioning unit element is there, whatever the output that is given by the signal conditioning element need to be processed. Then you are going to get the data presentation that is called as a measured value. True value is different, measured value is different. There is no condition that the measured value should be same as the true value. Okay, that is why we require to use the closed loop control system sometimes, which as per the need. Just I will be telling here, stage 1 detection transducer or a sensor transducer stage is called as Bourdon tube, and the stage 2 signal conditioning stage, where example gearing, filters and bridges, and stage 3 a terminating or readout or a recording stage. That is, even you can take the printing also. So that depends upon the requirement. So now again just I will be considering whatever the need is there. According to that, a sensor, just I will be defining it. It is a device which senses and detects the quantity being measured and responds by giving the output signal, generally in the form of voltage. Signal conditioner, it is a device which receives the signal from the sensor, manipulates, means it makes some changes, the signal into a condition suitable for either display or controlling the system. That is why you can either display it, or the same signal can also be utilized for controlling the certain particular parameter or physical quantity. The third one is called as a display or output, a device that displays the output either in analog or digital. The best example which we have taken is a thermocouple, is a sensor. Okay, suppose if at all I want to go for the measurement of a temperature, then generally we take thermocouple as a temperature sensor, and amplifier is a signal conditioner, because whatever the output we are going to get from the thermocouple is in the form of millivolts, it has to be amplified. That is why we are going to use the voltage amplifier. So such an amplifier we are going to call it as a signal conditioner. Then you are going to have from the amplifier pointer moving on a scale, that is a display, or it can be even converted into a digital form. Okay, so now let me consider, as we have already discussed the important point in connection with the measurement system. Whenever we are going to design a mechatronic system, the mechatronic system can be of two types, as I already told. That is, it can be used for the measurement purpose, or sometimes we need to use for the controlling purpose. If we are not using for the controlling purpose and the measurement system has no value, Very, very important. Simply by measuring the temperature in the room is not sufficient. We require to control the room temperature, especially in case of air conditioning system. A control system, let us define the control system now. A control system can be thought of as a black box which can be used for controlling its output to some particular value or sequence of values. So whatever the value that we are going to get in the output side, it has to be controlled. Example, central domestic heating system is an example of a control system where the required temperature is input and the output is a set value. The same, it can be explained by a simple block diagram. You are going to get the input is nothing but a required temperature which is given to the control system. Output, you are going to get the temperature at the set value, means what value I need is to be considered. Example, the same control system which you are going to see in your day-to-day life. Suppose if at all I want to, if you are having a vehicle, a two-wheeler, four-wheelers, whatever is there, when you are going to cross across the traffic lights, you are going to come across green, yellow and red signals. So this is called as a sequencing. This is called as a sequencing, time sequencing. That is, in other words, it can be also called as a control system, because the traffic is controlled by setting a particular timing in the form of seconds or minutes, whatever the requirement depending upon the traffic flow. So example is what? Traffic lights control system, central domestic system, washing machine. In washing machine also you are going to control, the timer is there, you are going to set the timer as per the requirement for soaking, for rinsing, for drying, etc. Okay, which is available, and then you are going to start the machine like that. The next one, the most important thing that you need to understand here in control system, basically a control system is a system wherein we are going to control the physical quantity. Whatever the output we are going to get, we are going to control it. But in controlling also there are two types. One is called as a open loop control system and the second one is called as a closed loop control system. So in open loop control system, so as the name itself implies, the control action is carried out with reference to the given input known as a set point but without a feedback. So what we are going to do here is the input is given to the controller. Directly we have shown the controller, even you can also have a sensor also. Okay, here the input is given to the controller. The controller in turn will send the output signal to the controlled process, what we want to control, whether I want to control the temperature, pressure, all, then it can be given as an output. So here what we are going to do here, whatever the output is there, I am going to get. Okay, that output need not be according to what input is given. There is no relationship between here input and output. In other words, the output is totally independent of the input. Whatever the output I am getting is totally independent. So that is why this is not more accurate. Okay, so now let us have an understanding about the practical applications where the open loop control system can be used, which you are going to get in your day-to-day life. Electric hand dryer. I have taken an example of a electric hand dryer. Okay, so hot air, when you are going to make your dryer, if you are having a dryer house, you are going to make certain knobs, how much, at what rotation speed the hot air has to come out of its mouth, whatever is the outlet is there. You are just going to, what you are going, that means you are just going, the air is sucked and it is heated and it is sent through the coil, okay, wherever I want. Here, this is called as an open loop system, okay. And automatic washing machine also, just you are going to set the timings according to the preset time, irrespective of washing is completed or not. So what we are going to do, we are going to set for 30 minutes, 45 minutes, 1 hour, etc. We don't know in 30 minutes the entire clothes get dried. There is no guarantee, but the setting is done in that way. So such a system is called as open loop control system. Similarly, bread toaster. In bread toaster also we are going to adjust the time to what time the bread is to be dried as per the baked. Okay, as per the requirement. So that is why here also it is called as an open loop control system. Automatic tea or coffee maker is also coming under the same. Time based clothes dryer, light switch, volume on stereo system. Whenever you are going to you require to increase the volume or decrease the volume as per the requirement in a stereo system. but there is no facility that automatic, as per the requirement, automatic adjustment of increase or decrease of the volume. So these are around 7 examples of practical applications wherein the open loop control system is being used. Now let us have a brief understanding about what are the advantages of open loop systems or open loop control systems. The first one is simple in construction and design. You are going to see the design is very simple. We require to have a control, signal conditioner, output. Okay, so that is why simple in construction and design. It is economical, it is not that costly, easy to maintain, maintenance is easy, generally stable, it is stable, convenient to use, as output is difficult to measure. Convenient to use, as output is difficult to measure. It is not possible to measure how much output I am getting by using this system. Disadvantages, they are inaccurate. As I already told, that whatever the output we are going to get, okay, it need not be exactly what exactly we need at the input side. That is why it is inaccurate. They are unreliable. That is why definitely it is unreliable, not reliable one. Any change in the output cannot be corrected automatically. Suppose whatever the output I am going to get, it cannot be corrected. Whatever it is going to give, that only I have to accept it. So these are the certain disadvantages. Now let us come back to the closed loop control system. So in a control system, we are having two types. One is open loop control system and closed loop control system. A closed loop control system can be defined as a system that has a feedback loop, that is a control system that uses a feedback signal to generate the output. Whatever the output that is generated is completely in a closed condition. That means whatever the output I am going to set, suppose if the outside room temperature is 45 degrees centigrade, I want my room temperature to be 25 degrees centigrade. Exactly 25 degrees centigrade you are going to get in the room, provided your system is provided with a closed loop control system, otherwise not. So similarly, in an open loop control system, you have set for 25 degrees, but there is no guarantee that you have got a 25 degrees. It may be 28 degrees or it may be 24 degrees, because we cannot control the temperature, because we are not getting because your control system is in such a way that it is not possible to have any control over the output that we are getting into the room, whatever the set that I need like. The stability of this system can be controlled by a feedback system. So by providing a feedback system, any open loop control system can be changed into a closed loop. By a very small modification, the same open loop control system can be converted into a closed loop control system. So let us have a brief understanding of basic elements of a closed loop control system. If you are going to observe the basic elements of a closed loop control system, here you are going to have five important elements. Okay, the first one we call it as a comparison element. The second one is called as a control element, and the third one is called as a correction element or correction unit, and the fourth one is called as a process element, and the fifth one is called as a measurement element, that is a measurement device. So if you have got a keen observation, you are going to have the reference value, that is nothing but what value I need. It's called as a value that is given to the comparison element. Again, here also the same system. A certain physical quantity is being sent with the help of a sensor to the comparison element. It compares and gives that signal back to the control unit. Control unit, whatever controlling action need to be done is taken care by the control unit, and whatever the same signal is sent to the correction unit, the correction unit takes care of correcting the value given by the control unit. And the process maybe means what I need to control. The process can be controlled. Then you are going to get a controlled variable at the output side. Then that controlled variable is sent back to the measuring device. This measuring device which you are going to see here, sometimes it is also called as a feedback device. It is sent back to the comparison element. So the comparison takes place, and again we are going to send the error signal. If you have got a keen observation here, the same system can also be open loop, provided if we don't have the measuring device. If we don't have a measuring device, then it can be what? It can be only a closed loop. Just have again definitions Let me revise. Comparison element, it generates an error signal. So this is the variation of the input as well as the feedback signal. Okay, it compares the output measured value with the required value and produces an error signal. That is why it is sometimes called as a comparator. In comparator also you have got two types, analog comparators and digital comparators. Basic function of a comparator is to measure the standard value with the value that is which we are going to get from the output side, and whatever the error is there, that error will be sent to the controller or control unit. The second one is called as a control unit. It generates an actuating signal to control the system. In this arrangement, the control system output can be corrected automatically to get the preferred output, that is called as a thermostat. The control unit can be an example of a thermostat. If you are going to have a simple iron which is having an indicator, you are going to set that to the required temperature which you need before ironing. That means we are going to have certain range from cotton to silk, whatever is there. So you are going to set that temperature. When that particular set temperature is reached by your iron, then automatically the thermostat will shut off the current flow. Then the further charging or further heating of that sole plate of the iron will be stopped. So such a system can also be called as a closed loop control system. So it produces, let us have an understanding about the correction element. It produces a change in the process to correct or change the controlled condition through an actuator that provides the power to carry out the control action, that is called as a heating element. The process element is what? The process is something that is being controlled. That is, it could be a room with its temperature being controlled or a tank of water with its level being controlled. Okay, here we have taken an example of sole plate of iron. It can be a level of water to be controlled, or it can be a temperature of room to be controlled, or it can be a temperature of the sole plate of iron to be controlled. In all the cases, this is called as a process element. Measurement device. This element measures a processed variable to give feedback about the actual value to the controller, that is called as a sensor. Here, measure device means basically it is called as a feedback device. We require to have a particular sensor which senses again the output taken from the process element, then it is sent back to through the measuring device, that is a feedback device, and then again it is given as a signal to the comparator for comparing its value. So, and whatever the error signal is there, that error signal is again sent to the control unit. So that is very, very important. Now, what are the certain, let us go to the certain examples of closed loop control systems. The first one is called as a thermostat heater. Just I have taken an example of an iron, sun seeker solar system, voltage stabilizer. In voltage stabilizer also, it is going to shut off whatever the requirement of voltage if it is exceeding a certain limit. Okay, a missile launcher, auto engine, inverter AC, automatic toaster, turbine water control system at power station. All these are practical applications where you are going to see around in connection with the closed loop control system. And let us have an understanding about the advantages. So as I already told, the open loop control system, it is unreliable, it is very difficult, but only the construction can be easy. But here there are various advantages of using the closed loop control system. The first very important is called as the accuracy. Compared to the open loop control system, okay, they are more accurate due to their complex construction. Okay, they are equally accurate and are not disturbed in the presence of non-linearities, because whenever I want to go for the design of a particular system, there should be a linear variation between input and output. Noise reduction ability. Since they are composed of a feedback mechanism, so they clear out the errors between the input and output signals and hence remain unaffected to the external noise sources. There is no question of any disturbances in the movement or in the flow of a signal in the entire process. Okay, what are the disadvantages? The disadvantages is construction. They are relatively more complex. The design becomes more and more complex as we use it, as we convert open loop to closed loop, and hence needs adds up to the cost. Definitely the cost also gets increased. It is costlier than open loop control system. Okay, since it consists of a feedback loop, it may create oscillatory response of the system and also reduces the overall gain of the system. Stability, it is less stable than open loop system, but this disadvantage can be struck off since we can make the sensitivity of the system very small so as to make the system as stable as possible. An attempt is made to see that the closed loop control system works with a lot of stability, because every time the system has to run in such a way that the desired set quantity has to be, physical quantity has to be maintained by using such a system. Okay, and I'm going to end with the today's session, and at the same time I am also giving some videos in connection with this. So it is your responsibility to see that you are going to view them, and then you should be in a position to answer the questions, whatever the questions are there which you need to understand. Okay.
You will be able to define measurement, describe the importance of measurement, explain the structure of the measurement system. An act or process of measuring any entity is known as measurement. Is measurement really important in our life? Come on, let us explore the answer. We use various electrical appliances at our home. The power consumption is measured and monitored by the energy meter. The kid is feeling sick. What is the first thing that her mother will do? She measures the body temperature using a thermometer and later takes her child to the doctor. While traveling, the fuel meter in her car indicates that the car is running out of fuel. They reach a fuel station to fill fuel. While filling fuel, there is a meter to ensure that the required amount of fuel is filled in the vehicle. While pumping air into the car tire, there is a meter to monitor the air pressure. To monitor the speed, there is a speedometer in the car. It is only the measurement of any variable or entity that helps us to make or break control over that entity. Without measurement, control is not possible. Hence, measurement is very important in our day-to-day life. For an effective measurement of any quantity or variable, we need a well-organized and structured system. Such a system is known as measurement system. Let us explore how the general measurement system is operated. An instrument or device used for measurement has a structured system. The prime elements of a measurement system are primary sensing element, variable conversion element, variable manipulation element, data transmission element, data presentation element. These elements are arranged in such a way that the primary sensing element makes contact with the entity to be measured, and the data presentation element gives information to the observer about the quantity measured. It is not necessary that the manipulation element must succeed the conversion element. It can be placed as per the requirement. Let us understand better. We all consume aerated drinks. Can we carbonate the drinks at home? Yes, we can. All we need is a CO2 tank with a regulator. The taste of the drink is enriched by injecting CO2 into the liquid. The pressure gauge is placed to monitor the pressure of the carbon dioxide. Here, the measuring instrument is the pressure gauge. How does the system work? The Bourdon tube acts as both the sensing and the conversion element. Here, the entity to be measured is the pressure. The Bourdon tube senses the pressure. The major function of the variable conversion element is to convert the output of the sensing element to another form. When the pressure is sensed, the closed end of the tube is slightly displaced. Here, the pressure is converted into small displacement. The mechanical linkage connecting the Bourdon tube and the gearing arrangement contributes to the data transmission element. The main function of the transmission element is to transfer the signal from one element to another. The mechanical linkage transfers the displacement from the board and tube to the gearing arrangement. The variable manipulation element manipulates the signal presented to it without changing the nature of the original signal. The gearing mechanism contributes to the manipulation unit. The gearing mechanism amplifies the small displacement so that the pointer rotates through a larger angle. The display devices show the information about the measurement to the observer from the data presentation element. Here, the pointer and the dial arrangement gives an indication of the pressure signal applied to the board and tube. This is how the general measurement system works. Measuring instruments can also be used to establish the control over the input. To have a control over the input, we need a feedback and a reference value. This is known as control stage. If there is no discrepancy between the measured signal and the reference signal, the controller does nothing with the input. If there is a difference between the measured signal and the reference signal, the input is varied to get the desired output. Let us see in detail about the controlling function of a measuring instrument in the next module. Summary. From this lesson, you have learned measurement and its importance, elements of a general measurement system and its functionalities.